Ha. Well, hey, Brenton.
How's it going?
Good. How are you?
Doing great.
Sorry, I'm just eating like my dinner of crackers and popcorn. How's life? Did we lose Ken? Oh no, he just has his mic off.
I'm on.
So, shall we kick it off? I'll do question one, part one. It says, what is simple linear regression? Explain. I said, simple linear regression lets us find a simple linear equation that fits XY data.
I agree with that.
Number 2, what is the formula on the wiki in terms of y level? Represent the linear equation used to estimate a line relating to the variables x and y, assuming linear relation exists between these two variables. So the relationship, I guess, is that equation then y equals bo plus b1 x times x, right?
Question 3 says, for the line y equals 1.34 minus 2.2x, what is the slope? And I put negative 2.2.
Right?
Oh, I don't know why I have 2.2 there. I must have something wrong. Oh yeah, because it's minus. Got it. Thank you.
Y equals mx plus b, right?
Right. So number 4, for the line y equals 1.34 minus 2.2x, what is the y-intercept? I put 1.34.
Right?
Yep.
Okay, number 5, using the prediction line above in number 4, predict the value of y for the input value of x equals 5. So if y equals mx plus b and y then equals 1.34 minus 2.2 times negative 5, that means y is equal to negative 9.66.
Yep.
Okay, good. That's what I have. All right, who's up for part 2?
Part 2. I'll start it. You'll complete this with your group. Use the crocodile thing to pull that up. And what is the explanatory variable? Hold on. Okay. Crocodile.
So
Is the file we're using the one from this week's, like, this lesson, the estuarine crocodiles?
That's the gyral crocodile data. I think the same one that we looked at last week. Is that right?
The other day, too. Wait, what is it? Yeah, Tuesday.
The other day.
Tuesday, too.
you're looking at the Guarial crocodile?
Guarial, there you go.
Or how, I don't know how to say it.
Yeah, me neither.
I guess there's no U in that, so maybe it's Guarial. So just a quick thing about the explanatory variable and the response, or in other words, the independent and dependent. In this case of crocodile head length and body length, couldn't it be either way? I mean, couldn't you make the body length the explanatory variable and the croc head length, therefore, is the response? I mean,
I guess
Well,
it's a chicken egg problem in my mind.
Doesn't it depend on how they've structured the study?
Oh,
Like
sure. Well,
if-
in this case, they had to have the head length to determine the body length because they didn't have the body of the crocodile they found anciently in
Yeah.
the text. But I just, in my mind, you could have, maybe you had the body, but you were missing the head, and you could have just done this in reverse just as well.
Yeah, I think that's possible. Yeah. What about is one variable like that? Is there one variable that's used for, say, grouping or something like that, while the other one's just kind of at random? I thought the explanatory variable could be used in the structure study like as a grouping variable, but the response variable is just whatever incoming data they get off of it without. I don't know though.
Yeah, I mean, in the case of the manatees, it seemed clear that one was causing the other, right? The number of boats was causing the death of the manatees. So you couldn't say, well, the more that manatees die, then the more boats spontaneously arrive on the water. That wouldn't make sense.
Sure, exactly.
But anyway, so are we all looking at this data?
Yeah, so mine just finally loaded.
We can look on with Kent in the screenshot.
What's that?
We can look on with you, Kent, in your
Sure,
your
if
screenshot.
it's clear enough for you guys. Try to blow it up a little bit. So, have we done number 1 yet in part 2?
No.
So I just put that the explanatory variable is also the independent variable, or x.
Mm-hmm.
In this case, it's the croc head length.
Okay.
That's what I thought. Mhm.
All right, then it follows that the response variable is the dependent or y variable body length, right?
Right.
Create a scatter plot representing relationship between head and length and body length. Gotta put it on here. Everyone okay on the graph?
Yeah.
Okay. Should we go into number 4 then?
Sure.
Sure.
It says use the software to compute the value of the y-intercept in the regression line. Report the value below. And I got negative 69.369.
That's what I have.
Yeah.
And then in number 5, use the software to compute the slope of the regression line. And that's 7.4.
The equation for the regression line computed by the software is y equals the negative 6.69.369, then plus the, what do we just get for the slope? So 7.4 times x.
Right. Is that what you guys have for that? Let me check the answer key too. 'Cause it said use the software to compute the regression line, and I wasn't sure what that meant. That just meaning just giving us the slope and the intercept?
Mm-hmm.
Yeah, so you just put that together to make your.
Okay.
Your
I just wasn't
equation.
sure if there's something the software was missing. So I could add a cell to just make the equation for us. Anyway, I'm sure you guys
Yeah,
can all do that
perfect.
too. And then, Stephanie, you want to take on number 7? I haven't gotten this far yet.
Yeah, software to draw the regression line and the scatter plot. There. So the scatter plot that's on our spreadsheet there. So just draw a regression line. Okay.
We can put a regression line through the scatter plot.
Right through the middle, yeah.
Does anyone want to screenshot how to do that? Or screen share it?
I'm showing my screen right now.
Brenton, is your screen sharing working?
I hope so. Let's see.
Is it working for everybody else? I just see it black.
Yeah, it's I just see a black screen.
Oh, now I can see you.
All right, here we go. Tell me
Okay,
if you
cool.
can see it now.
I got it now.
Yep.
So how did you make that line?
I just went on to insert in Microsoft Word and went to shapes, and I just grabbed one of the lines and I
Just drew it on there.
inject.
Yeah, that's what I just did.
Okay.
Right through the middle.
Oh, okay.
Yeah, I was wondering if there was a place where you could type in the equation too.
Yeah, that's what I was wondering. Okay, so we just, okay. So you just drew the line in.
Uh-huh.
Huh, I wonder if there is a way to add that.
I really don't know.
Yeah,
I'll have to research that later.
Yeah.
Yes?
scatter plot or to add the line automatically.
Okay, so number 8, Rhett, do you want to take on 8?
I didn't get this far.
Okay.
Well, yeah, this is just a group one anyways.
Yeah.
Mhm.
I'm not sure if any of us did. I didn't.
All right, I'll just read it. It says, for the observed head length of 51 centimeters, what is the observed body length? Look in the data file to find the answer. So
The observed head length 51.
just look at that particular entry.
So 343.
343, yep.
Right.
Okay. Use the regression line you obtained in number 2 to predict the body length based on head length of 51. So would we use that negative 69.369 plus our slope, what was our slope? 7.4,
Mm-hmm.
and multiply that by, I guess, what is x? 51? Or is that the 353?
Yeah, it's 51.
51. Okay. Oh, negative 69.
So what are we doing? Are we just plugging this in the formula
Yeah, we're just plugging in,
for y?
plugging in
43.
51 into the formula, and then on 10 it's asking us if there's a discrepancy. Why do you think there is one? What does that mean?
Well, because the I think it's that perfect line that the equation gives us is kind of the center of the data, or the median. I don't know how to describe that, but it would be kind of like the center of the data, and everything's kind of scattered a little bit around it.
Right, exactly.
In fact, we could describe the scattering by just looking at our coefficient. So it's pretty tight. It's a 0.986.
Yeah.
Pretty tight relationship, but there is some variance, and that variance is why there's a difference.
Right.
Wait, what did you guys get for number 9?
Number 9, 308.031.
Yeah, and on like the Excel though, mine is saying, so that's what I got when I put it in the calculator, but in Excel it says 308.023. So, which one should I trust? Well, I mean calculator, I guess, but that's up to him. Never mind. Well, you try the quiz?
Yeah.
Sounds good.
Wait, some
How'd you
question.
guys work out the math on that 9 so quick? Aren't we solving for x?
On number 9?
Yeah.
No, because we're using the line of regression. That's the y value formula. So that's the one you got a couple questions back where it was y equals the
You're just plugging the length of the head observed in question 8, 51 centimeters, in the place of x.
It's
Oh,
basically
on the spreadsheet.
yeah.
Yeah.
So predicted 308.033. Is that the answer?
031. At least that's what I'm getting when I put it in like the calculator on the computer. But there may be some additional precision that we've lost on it. I don't know. No, I don't think. No, I think that's right.
But you're talking on the spreadsheet in this box here. I have x, and then I put in 51, right?
Mhm.
And then predicted should spit out some numbers.
What is yours saying? Can't we do that? Oh yeah, yours says what mine says. That's why. I mean the calculator I got, and I just checked it was the point
You see
zero.
that x, that gray box under x?
So yeah, I mean it looks like it might be a rounding error. Because the y-intercept is probably longer than just negative 69.369.
Oh, right. Okay.
So I know the key has it as 308.031 also. So I'm sure they're just taking those numbers and putting them in that way, but I wish they would just be consistent about it.
Just to give you guys some intel from the office hour today is actually when we're plugging in our answers in quizzes and exams, it's not an exact answer. It wants a narrow range.
Oh, okay.
So a lot of times when we get little anomalies like this, it'll be okay on the quiz.
Oh, that is really good to hear.
Yeah, because the other night kind of worried me.
If it's not, and we get it wrong for some reason, but it's like really close, the professor, like he would, take a look at those and make corrections. If they're like 2/10, he was using language like 2/10 off or stuff like that. So.
Okay.
I'm sorry, guys. I'm just gonna go tell my home to be quiet. My roommates are screaming at each other. I'm so sorry.
So what's the deal with this paper? Are we all gonna just write it, or what's the plan?
So yeah, so I guess we're supposed to make a slideshow, right?
Oh, is that what?
For this
that
week,
was
it's
due
actually
Saturday?
describe the data.
This week's just describe the data, okay.
Oh,
And
yep.
I thought it was only one person had to, but we could certainly collaborate on it if you guys wanted to.
Sure. Well, I'll just put a document up in there, and then we can all just work on it. I did
Sounds
talk
good.
to him, though. He said that it's important that we describe our data. He says we can take whatever approach we want because he agrees that the proportion test is the wrong test for this. He's
Okay.
going to leave us graded the way we were for our previous two, so we won't have to redo any of that. But he said
Okay.
for the describe the data, let's just present it in the way that maybe the study should have gone. And because we all used bags of different sizes because we were looking at proportions, so it wouldn't have mattered, we can't use a t-test directly. So I ran by him two ideas. First is just to use the proportions as our t-test because that actually works.
Okay.
That would be the easiest. And the other one is to extrapolate. Obviously, we didn't measure each weight of each nut and kernel, but we can extrapolate how many nuts are in and out and how much then each nut weighs, and we can make extrapolations like that and then present the data as if we had 1,500 data points because we measured each nut, which we didn't. So that would be kind of the less honest way, but it would be more true to the t-test.
And he said that that would be okay to do just for the purposes of this, like this exercise.
He left it up to us because I think I was overwhelming him because, of course, I know all about the study because we did it, and I'm just kind of walking him through it. He's not looking at anything directly. I'm just kind of talking him through kind of our problems. So he just kind of said, well, how about this? You guys just kind of work it out the best way you think you can, and then, just present it that way. And I trust that you guys will. He says if it's awful, I'll just let you guys redo it.
That's great. Okay, good.
Well, that works, yeah.
It doesn't get much better than that.
If we get a second shot, then that's awesome.
Yeah. So how
I guess we can, once Kent puts up the document, we can all go in there and edit it and.
Right.
Put that up right after our meeting.
Wonderful.
And then you guys just want me to submit it then? Is that the plan?
Are you on the ticket for this one, Rhett?
Yeah, that's me.
All right, cool. Yeah, why not?
I think the easiest thing to do is to have Kent put it up and then have Rhett type it, and if we have any changes that we want to make, just let Rhett know and then make those changes until it's due on Saturday, and when it's due on Saturday, we can just submit it.
Sounds good.
Brett, did you get grades for the first and second part?
Yeah, I had a email him. He just said, like, your guys' group was, like, just automated, I guess, and I'm not in there, and so he just has to manually put me in.
Okay.
Is there anything else that needed to be done for that?
It looks like they're not going to give us a template for this to describe the data. But it gives us some guidelines. I'll just post this in the group folder so we can reference it, but I'll just create a new document to actually work on.
Very cool. So let's wrap up the lesson 22 prep. The last one is, why are the values you obtained in 8 and 9 different? Explain. And we just talked about that, right?
Yeah.
Yeah. One is an approximation, and obviously the real data doesn't always reflect that. All right, cool. So are we ready to begin the quiz?
Ready.
Yeah, let me get there. Thanks for hosting, by the way, Stephanie.
Oh, you're welcome.
Yeah, nice. Thank
Sorry
you.
it always takes me so long. I don't know. I mean, it's really not that hard. Some nights my brain is just, less tech savvy than others. I apologize.
I just hate when I'm hosting and my mic doesn't cut down or, some technical problem seems to always happen.
Yeah. No, it's not a problem. Okay.
I'll just start us off real quick on 3 and 4. So 3, I got 2.0. 4, I got 1.5.
I agree with both of those.
I agree with that as well.
3.0 and 1.5.
And then on question 5, it says, give the linear regression equation. What is the predicted value of y when x equals 16? And I got 1.0.
I got that.
Yep. -1.
-3 plus 2.5 times 16. We got 1. That 0.0 according to the answer.
A quarter, that's 4 plus -3 is 1. Yep. Round to 1 decimal. Should we say 1.0?
That's what I'm doing.
That's what I
Right. Also, one more thing from the office guys that will pertain to this next question is, Rhett, were you by chance using an old, when we were on the last quiz, you remember you and I were giving the same answers and we thought it was because of our Office 2016?
Yeah.
It actually has nothing to do with that. It narrows down to two things, either because we were using data files from the beginning of the semester that might have changed mid-semester.
Oh.
I don't know if that's true for you. Is that?
Might be, yeah.
Because, I mean, I've been using, I just downloaded all the data files at once and I've been using them. So it could be that, or the other thing is, that I might have noticed, is that, does your data file just open up in Chrome, and then you copy from Chrome and then paste the data into Excel?
Yeah.
Yeah, that's what I do.
Yeah.
So when I do that, I get, for whatever reason, I get a slightly different answer, and I can't figure out why.
Huh.
But if I download the Excel file and open it in Excel and copy and paste from Excel, I get the answer that the professor's getting.
That's really interesting.
So I can't explain why, but I think it's better safe just not to use Excel and Chrome with the same sort of data. Just do all one or the other, I guess.
Yeah, thank you for the insight on that.
Anyway, I guess we can. I can't download these easily because they prohibit right-clicking. I can't stand that.
I know.
If you download it in Chrome, if you open it in Chrome, there's a button at the top that says download that you can use to download the file directly after that.
Well, I have a download manager that tries to hijack links and stuff. I just have to.
Oh, that'll work too.
I'm gonna disable that and see what happens.
Number 6. I got hot dog shape.
Yeah, I guess so. It's kind of a weird question, but okay.
Still pulling up.
What was that, Kent?
I'm just pulling this up.
Yeah, hot dog shape. There you go.
Well, extremely beneficial to know that for our higher education here.
I think it's more of a severed hand shape.
Yeah, it's pretty graphic.
Yeah, I don't think hamburger or banana fits, so I'll go with hot dog. That's the most scientific answer I can come up with.
Right.
I didn't know Dan's severed hand was a good idea, too.
It looks pretty accurate, doesn't it?
Alright, should we go into number 7?
Sure.
Sweet. Alright, just says, based on the shape of the scatter plot you produced in the question, what can you say about the appropriateness of using simple linear regression to model these data? Let's see, what were the rules on this?
I'd say it's appropriate.
Yeah, I think so too.
Yeah. How many observations are in the data?
39.
39? How many?
I thought there were way more.
140? 139.
139. Okay.
I was like, I think there's a little more than that.
You and me both.
139.
Alright.
What is a y-intercept? So, what is a y-intercept?
1.296, right?
Oh, I don't get that. I get
1.296.
1.239.
Oh,
Uh-oh. What's
I get
everyone else getting?
1.296. I get 1.296.
1.296.
What about you, Rhett? What do you get?
18.559.
For the y-intercept?
Yeah.
On your Excel sheet?
Do you have some Aaron data, some like latent data from a previous?
Yeah, I clicked it in wrong.
Okay.
Yeah.
Did you figure out your problem, Dan?
No.
You're
Doesn't make any
sticking in?
sense.
You're sticking to it?
No, I'm going to go with you guys. 'Cause
Did
I
you
know
put your
this.
document at the file from the quiz, or is it one of the ones you already had previously downloaded?
I pulled it from the quiz.
Hmm.
Yeah.
I pulled it from the quiz and opened it up in Excel. What did you open yours up in?
I downloaded it and opened it in Excel. Yeah, I get 1.239.
And you have 142 line, the 142nd row is the last row of data.
Oh no, I have the 141st.
Oh, then you're missing one line.
What? Mine only goes to. Oh, mine goes to 142. Yeah. Yeah, Dan, you must be.
It does, huh? Very odd.
So then, Brent and Stephanie, are you guys getting 0.042 for slope?
Yes.
0.0. Yeah.
So if x equals what's that?
I think I know what may have happened. So when I pasted it in, they have a merge of cells 2 and 3, and I did not realize that they had merged those two.
Oh, so you paste it into 3.
Yeah.
Okay.
So I ended up with one fewer rows, and I think their formulas are looking for very specific, I don't know, range. You know, they're not looking at below 2. They're looking at 4 specifically, explicitly 4 through whatever. So
Right.
pretty sure that accounts for it with me. And
So does someone want to hand compute this to check? But for 11, what's the predicted value of y? When I plug it into the spreadsheet, I get 1.462.
Yes, that's what I get. Let's see.
okay, so sorry, I'm catching up with you guys. So y-intercept 1.296. All right.
And then for your slope, what do you get, Dan?
Slope, I get 0.42. What? I'm sorry, 0.042.
Yeah.
Yes.
Okay. And predict value.
I'm getting 1.464 when I plug it in the calculator. Hold on. So we would do, if we do it this way, the 0.042 times 4 plus 1.296, right? Yeah.
Yes, 0.042.
So when I punch
times-
it into the calculator, it's 1.464, but in Excel, mine said 1.462. Last time we did this, though, the correct answer on the answer sheet was the one on the calculator. So should we just go with that? What is everyone else getting?
Well, the people that are doing the answer keys, though, I think they're just TAs, and it's not as accurate. I think I'd rather trust Excel because it's not cutting off 3 decimals in every part of the equation.
Right.
Okay, so when you put it into Excel, how are you going about doing the calculation?
See the blue box under X?
Yep, so you just put it in there?
Yeah, I just put 4 in there, and then it predicted as 1.462.
Got it. Yeah, I think if we just use the tool throughout, we're probably going to be safe.
Yeah, and you're getting 1.464 with the calculator. That's what I get.
That's what I got too with the calculator.
I bet you this. I mean, when it cuts to 2 1,000ths, I don't think it's gonna have an issue.
Okay.
I'm going with the spreadsheet.
All right.
The confidence data resulted from students evaluating the confidence for each on a scale of 1 to 6. What is the maximum predicted value of y for these values of x's? What?
The maximum predicted value of y for these values of x.
From 1 to 6. So do we just plug in 1, 2, 3, 4, 5, 6? Region?
Because in a positive correlation, we can use the largest x value to find the largest predicted value of y. How does it result in
Well, 6 largest predicted value is with 6, and it's 1.546.
Mm-hmm.
Are we like missing data for this or something? I don't get it.
I just kept plugging in 1, 2, 3, 4, 5, 6 under x. That's what I did. But yeah, the highest value that gets is 1.546 if you do it that way.
And if it's a linear equation, you can look at it and determine which end of the scale is going to be the high end pretty easily.
Well, can't we just, aren't we just going to be plugging in for y and then solving for x for the equation? Isn't that how we get the answer here?
Well, that's kind of what you're doing if you're plugging in the x.
Yeah.
But that's what we just did on the calculator, and you ended up going with Excel. So if you punch it into the Excel, it should get the 1.546.
How do you do it in Excel? I must be missing that.
So you know where you told me to put in the 4?
Uh-huh.
If you just put in 6 there.
Right, but that's going to be for, is that for x or y? What is 6? 6 is not an x variable, it's a y variable, isn't it?
I think 6 is an x.
Oh, maybe it is.
Maybe I'm wrong.
Yeah,
Let's see.
it said what is the maximum y value for these values of x. So it is x.
Yeah. All right, we ready for 13? Okay, how many?
On 12, but.
Oh, okay. So let's go back to that for a second. So they're asking the confidence data resulted in, from students evaluating the confidence for each question on a scale of 1 to 6. Oh, are they talking about the same question?
Well, actually, we might be just predicted.
Yeah, they are. They're because it's the self. Yeah, they're asking about that. But I wonder if they're asking about the same data. It must be. So, I mean, those are the x values. They say that these values of x. So we know that we have to determine something about when x is equal to 1 through 6. And they want to know the maximum value of y. So if it's a linear equation, we just know that if it's a negative slope, we know that you're going to go with the lowest value. If it's a positive slope, we're going to go with the highest value. So we put in the highest value, 6, into the equation, and we get 1.546.
Wait, what is going on here? What's your top line in
My top line in the data?
Yeah, is it 50?
50 and 4.34. And then my lowest line is 70 and 3.77.
Yeah. Okay, yeah. That was what was confusing. My Excel spreadsheet was hiding a column from me. So. Okay, so yeah, the response variables are within that range. So it is a y value that we're looking for, right? So we can't plug in x equals 6 and get an answer. We have to work this out with a calculator, right?
No, we can because in the Excel spreadsheet, kind of like we did just for the question, like with the x value of 4, it's asking us what is that y value or the predicted y value, like in the chart, based upon the x values 1 through 6.
Oh,
you know what though?
Yeah, but the x values aren't anywhere close to 1 through 6. They're 50, they're 83, they're 76, they're 100.
So what are they asking on a scale from 1 through 6?
So we were on track, but take a look at the last 2 columns on the confidence and prediction intervals, and you'll see it says prediction interval for y, and it has a low and a high value. So I think
so we
they
gotta
want
take the
that high value.
2.907.
Yeah, 2.907.
Okay, I was wondering about that, but
Yeah.
2.907. But still, does that make sense though, Kent? It's still the same idea, we just looked at the wrong box.
Yeah.
So prediction interval for Y 2.907.
Mm-hmm. And is everyone else okay on that?
2.907.
That's what ours is getting. What about
Yeah.
yours?
I'll go with that.
So yeah, if you just put 6 in for X in the sheet and you look all the way over on the far right column,
Yeah.
you see that 2.907 is the highest possible predicted value for
Okay.
Y.
All right. Thanks.
Yeah, no problem.
I don't know. I feel kind of weird about all this. I'm gonna have to look at this data closely. I don't want to submit this quite yet because I just realized that for both the previous problem, question 11, when X equals 4, well, look at the data. When does when does someone get 4% on their test score?
Yeah. Well,
I think we're confusing our X's and our Y's, and maybe we need to be transposing this data when we paste it in.
oh, you know what? That's a good insight. Let's take a look at that.
Because the confidence rating mean column, that might be the explanatory column. I mean, I'm not sure on this, but they're asking us questions that wouldn't make sense.
That's a very interesting notion.
I mean, why would we ever put 4 or 6 into X when those values correlate very well with...
But at the same time, it's talking about the scale values though, because look at our scatter plot and the scale values is going by. So it's talking, isn't it referring to that?
Well, I'm saying, we might have all pasted our data in wrong. That's what
yeah, if we pasted it backwards, we'll be getting completely different answers than what we would expect. I think you're right, Kent, because if you look at all the X data that we have, it's all in the 70 to 90s range, or no, some of them are down to 50.
Yeah, well,
40.
Look at the information question. I'm glad that I kind of resisted on this. Be sure to use the confidence data, which is 1 through 6, or the explanatory variable.
Yeah.
That's true.
Or data as the response variable. We got it exactly backwards.
So yeah, so not only did we get it backwards on this one, but it's on all of them.
Okay,
right.
so
we need to
all
go
we have
back
to do though is just switch the...
reassess all this.
Yeah, just swap the columns.
They're pretty straight up answers though once you did that. So as long as we... Let's see.
I'm so glad you caught that, Kent.
I am too. I bet you when we find the test scores tomorrow, we're going to see some. We'll see someone that got it backwards.
Are you seeing more of a banana now?
Let me see. So my top line says 4.34 and 50.
Yeah.
And my bottom line is 3.77 and 70.
There we go. Yeah.
That's right.
I'm not really getting a banana. I'm still
It
getting...
still kind of looks like a... I don't know what that looks like, but...
Hot dog, severed hand, whatever. Something.
Yeah, it's
Hamburger? I feel like this is a dumb question. I'm very sorry. I think that's a stupid question. I mean, okay. If you wanted to look like a banana, you could, but...
Yeah, the banana only, that 1 point at the end is the only banana point that I can see, though. So I'm just going to say
stick with hot dog? Yeah. Well, alright. Let's breeze through this and reassess. So is this number 7? Do you think it's appropriate for the linear regression? I still think it's yes.
Yeah, I think so.
How many observations are there? That should still be the same.
That's going to be the same, 139.
Okay, so y-intercept, that's one we need to change.
Right, and I have
What?
18.69.
18.69.
18.69.
You got to put a 0 in there too. 'Cause that's what they want.
Yep.
And then...
Is that what you had, Rhett?
I think that was what Rhett originally had, yeah.
12.695. No wonder
Sorry,
Rhett
man.
was so confused. Sorry, Rhett.
Oh. All right.
What is the predicted value of y when x equals 4? Plug 4 in, we get 69.469.
And did you guys get 12.695 for slope?
Mm-hmm. Yes.
Yeah.
And
For
then
x equals 4, I'm getting
69.469.
Yeah, 69.469. What about that, Rhett?
Oh, no problem.
And then now 1 through 6.
Now I get 117.445.
Yeah.
I think we should still use that prediction interval of 117.445. Is that what you just said?
Mhm.
Okay.
On here, on the shared document.
Mm-hmm.
What is it?
How many explanatory variables are present?
More than 2. And then
What do
the
you-
dependent.
Wait, hold on.
2.
Wait, why did you say more than 2?
Oh, not more than 2. Wait, there's 1.
I was just going to say 1.
One
I was just
explanatory
gonna-
variable, right?
Yeah.
And then there's 1 dependent.
Right.
Then where are you guys finding that at?
That's just the information that was gathered, right?
Right.
So like what do we decide?
We have one variable for that's independent.
Confidence
and one
mean is the independent, and then the result is the dependent, right? Okay.
Right.
Daddy, how do you like
Well,
this?
do we all feel better about that?
Daddy, look.
Much better.
Yeah, I'm gonna submit mine.
Now, can you guys be sure to save all your answers? Because after you overwrite them, if you don't click save, I think it just reverts to whatever was last saved.
Yeah.
Yeah, save all.
Submitting comments.
Do you agree with the hot dog shape and the question 7 simple linear regression is appropriate for this data?
I agree with the linear regression, but I don't really know about the hot dog versus banana.
You know, I just submitted mine, and I will tell you that hot dogs look great. But the only one that does not look great is number 12.
Wait, so you submitted it, and what looks great?
Everything except number 12, which is...
Hot dog is
How did we
fine.
get that? Oh, I guess.
Did you put 1.5?
They said the answer is 94.859.
Oh, so they
So,
didn't use the
They
prediction
didn't use
interval.
the prediction interval. They just used the predicted y value.
Well, that's
For what question?
For number 12. So,
Did you say
I guess that's the confidence. That's the interval. It just, you know what? That's why, because it asked what the interval. I mean, the value for y was, and that's a predicted value. The one that we got was the predicted interval value. I guess it's different. I don't know, but that's the range of them.
I feel like it should be the 17, but
The confidence data results from students evaluating their confidence for each question. Let's get what is the maximum predicted value of y? These values of x. And because there's a positive correlation, we can use the largest y value to find the largest predicted value of y. And what was the answer according to the quiz?
It was
94.854 or 859.
859.
The predicted value and call each. See, and I mean, I'm just thinking, like, why would they use that and not? I mean, if they're talking about confidence, why would they not factor in the confidence interval? You know.
Yeah, I just wondered if we're not there yet in the text. I'm just scouring the text now to see if that was even covered.
Yeah.
predicted value is given the cell labeled predicted. So if I go back over here, yeah, I guess that they do mention in the text just to use the predicted one, not the prediction interval. I guess we'll probably do that next lesson or something.
Okay.
We gotta have
Well,
ourselves.
sorry, Stephanie.
Like question
okay.
13 with 1 and question 14 with 1, I'm not seeing that wrong, right? I mean, we just have one
No, everything
variable
else
in each.
was right. That was the only one we got wrong.
What did you say
Yes,
about
it's
number 4? Did you say we got something wrong with number 4?
Nope, all of them are right except that number 12.
Okay. Cool. Well, thank you, Stephanie, for hosting this. I'll put a document up for us to work on, and Rhett, you can kind of take the lead on that. And I'll just share the link in the Hangout. But remember, we've got to present the data. You guys can play with it. You have the data there in our in that same folder. But you know, however you guys want to deal with it. I think there's about 33 nuts per ounce. So if you wanted to compute what we didn't actually measure, we can do it that way, I guess.
Is that the kernel weight, or is that the whole nut?
I think it's the whole nut.
Okay.
But we could figure it out by just looking at the packaging. It usually will tell you about how many nuts are in an ounce or whatever.
Right. All right, cool. Well,
Well, thanks, guys.
yeah, thank you.
Thank you. I will post this.
Thanks, Stephanie. We'll see you guys
You're
later.
welcome. All right,
Alright, guys.
bye guys.
Have a good night.
You too. Bye.